Okay, so now I want to talk to you about one of the big ideas in Unit 1, and that is the idea of distance time and velocity time graphs. So distance time graphs, they're both visual representations of how an object is moving, okay? And so for distance time graphs, there's just a couple things you want to keep in mind. So we call them distance time graphs because, of course, those are the axes, okay? So you're on the y-axis is the distance that has been traveled, and on the x-axis is the time. Oh, sorry. Okay, and so for distance time graphs, all right, so distance time graphs are exactly what it sounds like. So the idea is that you have, if you have an object that is moving away from its point of origin, then that will be shown with a line like this. And then if the object stops moving, then the distance from where it began doesn't change. And so that would be shown by a flat line. And then if it starts moving again, it can move off slower or faster, and that would be shown with another straight line. Now, of course, you can have distance times graphs that are curved, but you won't for the iGCSE. All right. So the idea is that here, this part of the graph shows that the object is not moving or it is still. Okay. And then the idea is here it's moving at a constant speed, and here it's also moving at a constant speed. Now, how can you find out what that speed is? So the idea is that if you remember from our equations, we know that this average speed something is traveling is the distance divided by the time. And so that's going to be, the idea is that you find the value of the distance here. So if this is, say, uh, 10 meters, and the time here is 20 seconds, then you would put that in, and you know that your average speed is then 10 divided by 20, or 0.5 meters per second. So you're reading the graph, and the idea is that when you're doing that, what you've actually done here is you found the distance divided by the time. That is the y value, right? This is the y-axis, divided by the x, the change in x, all right? And so what you've actually done is you have found the gradient or the slope, right? So the gradient, sometimes called the slope, is the change or the difference in y divided by the change or the difference in x. And that's exactly what you've done here, right? What the change here from in the line, it went up by 10. And so that's your change in y, and it's gone over by 20. So that's your change in x. So 10 divided by 20, which is 0.5. So the idea for this is that the gradient or slope of a distance time graph is the same thing as the average speed of that object, right? The next type of graph that you see a lot of in Unit 1 is the velocity time graph, all right? And so the velocity time graph is the same idea, okay? You still have time on your x-axis. And now instead of having the distance on your x-axis, you have, or on the y-axis, you have the velocity. Right? And so now, if you have an object that the shape of the graph can look the same, but it means something different when you're looking at a velocity time graph versus a distance time graph. So for a velocity time graph, this is already the speed. So if you want to know how fast something is traveling at any given moment, then you're simply going to read the graph, right? So if this is, for example, 5 seconds, and this is 10 meters per second, that would be the units here. Okay, and time always in seconds still. Then you simply know that time at 5 seconds after beginning, the object was going 10 meters per second, okay? So you don't need to do the gradient or the slope in order to find the speed on a velocity time graph. That's literally what the y values are. Instead, the gradient or slope means something different, okay? The other thing that's saying is that this flat line here, it doesn't mean that the object isn't moving. Instead, it means that the object has a constant velocity, that there is no acceleration, all right? All right. So rather than not moving at all, the idea is that there is simply no acceleration. There is no change in the speed, which would be shown by a not flat line. And so when we are looking at the gradient or the slope of this one, if we want to find that, right? So let's take this point here that I already did. Then the gradient, right, is still going to be the change in y over the change in x. All right. And so the change in y here is 10. And the change in the time is 5. So you have 10 divided by 5, and that is 2. Now, what does that actually mean for this graph? So the idea is that you have velocity, the change in velocity divided by the time that was taken. That should look familiar from the first video that I made, which is here. Right, the idea is that the acceleration is the change in velocity, right? Final minus initial divided by the time. And so the gradient on a velocity time graph actually equals the acceleration of the object. All right, and so this is 2 meters per second squared. That's the unit. It's meters per second divided by seconds. Oops, sorry, can you see that? And so the idea is that it's 2 meters per second squared. So this is an acceleration. So on a distance time graph, the gradient is the speed, and on a velocity time graph, the gradient equals the acceleration. All right. Now, for the velocity time graph, there's one more value that they could ask you about in terms of the mathematical calculations, and that is the total distance that has been traveled by the object. And so if you want to know the distance traveled, then you need to find the area under the curve. All right, so again, if we take this point here that I've done, all right, then the area under the curve is going to be this triangle here. All right, so you do have to know your basic geometrical equations for finding either the area of a triangle or a rectangle, right? And so the area of a triangle is 1/2 base times height. This is the base here, so this is 5. This would be the base, and this would be the height, okay? And so the idea is that that's going to be 5 times 10. Make sure you can still see. Times 1/2. All right, so, oops, I mixed it up. But anyway, so you have 5 times 10, which is 50, times 1/2 is 25. So the idea is that in the first 5 seconds, the object traveled a total of 25 meters. So those are your 2 graphs, all right, that you will see and that you may be asked to do math on.